So with that, we will get started. So the first thing I want to talk about is the prerequisites. So I've just made a slide here so I don't forget anything. The main thing that you need to work with Phidgets in general is students need to have a basic understanding of code. So again, this is kind of what we've mentioned with the Getting Started kit, but conditionals, looping, and methods. This is something you'll see in basically every Phidgets project, every tutorial that we post online. So it's really important that students have understanding. Right now, we're recommending Phidgets to students in grades 9 to 12. That could definitely push lower depending on your school and your students. But this is something that we really recommend, is that they have a background in the language. So today we'll be using Python. So they should be comfortable writing some Python code and using if statements and things like that before attempting a Phidgets project, because if they don't, it's just kind of like layering complexity on before they're ready. And the other thing that we definitely highly recommend is the Getting Started kit. So this is the kit that looks like this. So you've probably all seen this before at this point now. It has the buttons, it comes with the VinTub inside, and it has the humidity sensor. So we really recommend that students, before they attempt to do the rover, they've worked through this course. And the reason for that is because in the Getting Started kit, we teach them how to create the development environment. So how to start a new project, import the libraries. And we also go over the general Phidgets flow, which I've kind of mentioned here. So creating an object, addressing it, opening it, using it, that's all covered in the Getting Started kit. So that the Getting Started kit's really the best way to introduce them to Phidgets. And then once they've gone through that, they can do more advanced projects like the Rover Kit. So we highly recommend doing that first. Okay, so that is the prerequisites. Next, I'm just going to briefly touch on what actually comes in the Rover Kit. So for that, what I'm going to do, I'm going to go to, I'm here at phidgets.com/education. And I'm just going to go to the Buy tab because it has some pictures of the kit. So if I scroll down, you'll see the Phidgets Rover Kit here. And if I click on the image, it'll actually bring up what the kit looks like. So this is what the kit looks like when you get it. So it comes in a box like this. So very similar to the Getting Started kit. It has the kind of name labels on the side. So if you have a student who's using this for the semester, they can write their name, and then you can kind of make sure that the inventory stays the same, or you can do an inventory at the end of the semester and make sure that that everything is in the kit that should be in the kit. So this is what comes in the kit. So I'm just going to open this in a new tab. So, there we go. So basically what we're looking at inside of the kit is, the first thing I'll touch on is the wireless VinTub right here. So that is this guy. So the wireless VinTub is the exact same as the VinTub that's in your Getting Started kit. So every Getting Started kit comes with the VinTub inside as kind of like the brain of the kit, basically. So in the Rover Kit, you get a wireless version of that. So it's basically the exact same thing. The only difference is that you can now, put this somewhere that's detached from a computer, which is really cool. So you get that as part of the Rover Kit, which is awesome. The next thing that you get as part of the Rover Kit is a DC motor controller. So it's down here in the corner, the DCC 1003. So maybe I'll pull up a better picture. So DCC 1003, which looks like this, and it looks like this. So another small little controller here. And the idea with this Phidget is that it gives you two ports, so port 0 and port 1, and you can control two different DC motors with it. And it again just plugs into your VinTub. So it uses the same kind of cable system that we've seen in the Getting Started kit. So you're connecting it to the DC motor, and then you're connecting the other end to the VinTub. In this case, it would be the wireless VinTub. But this allows you to control the motors of the rover. And the nice thing about this, I guess just as we're going and talking about it, is that, say the wireless VinTub, same with the DC motor, after you're done with the Rover Kit, you can actually take these off and use them in a different project. So the DC motor controller. You could use that to control a pump. You can use that to control a different motor. So it's nice that it's modular, so you're not just kind of putting your money into the Rover Kit. You can actually use it in different applications. The next thing that the Rover Kit comes with is the thumbstick fidget. So that is this guy. It looks like this, and basically it's a little like joystick, and it allows you to, we use it in this project so that students can write code to control their rover with the thumbstick. But again, the nice thing about it is that you can take it out of the Rover Kit after you're done, and you can use it in, we've had students use it in Pygame. We've had students use it in Unity. I've even just seen students creating a Java program where they're using this as like user input, just to create a slightly different, instead of just using the keyboard, they can use the thumbstick as their input for their project. So that's a really nice thing as well. So aside from that, you're getting the chassis. So the chassis looks like this. And the cool thing about this chassis is that you're getting it totally pre-assembled. So when you get this, I'll show you, it comes up in the course, but basically you just pull this out of the box like this. The battery's already attached, everything's attached, and all you're doing is you're just sticking on the Phidgets with some Velcro basically. So, and this comes with the battery, it comes with all of the required cabling. So the battery charger, the VINT cables, a little screwdriver, and basically everything you need. So that is what comes in the Rover Kit, and of course a wireless dongle here. And we'll talk about more of that. We'll talk more about that in the course. So that is a brief overview of what comes in, or not so brief overview of what comes in the kit. Okay. So the next thing I'm going to cover today is the course. So just like the Getting Started kit, we have an online course that we built out for the Rover. So we'll take a look at that now, and then after that, I'll go through the extra content we have for the Rover Kit. So again, by navigating to, I'm going to go back to our main website here for education. So phidgets.com/education. If everyone can get to that page, I'll just show you how to navigate to the Rover Kit. Give you guys a second. And if you have questions as I'm going through this, feel free to let me know in the chat. Okay, so if you're on this page, yeah, so, and Karen's saying regarding prices, the price points are important. Yeah, so this kit is actually an awesome, like a pretty awesome deal. You're getting, I think the full kit is $55. We've listed it at. Yeah, it's $55 US and 75 Canadian. And just to give you an example of what, like even just the DC motor fidget right here, we would sell this to our normal customers for $60 US. So you're getting the value in like one of the controllers, never mind the whole kit and the chassis and the battery and the course. So it's a pretty awesome deal. Okay, so navigating to the course. So what we'll do is just like the Getting Started kit, we're going to hit the Learn tab. So students should have experience with the Getting Started kit at this point. I'm going to talk about how device tutorials can actually work into the Rover Kit. So how you can kind of stretch your budget so that you can actually get more use out of the Rover Kit. But for now, I'm just going to jump right into the projects tab. So level 3 projects, and you can see the image of the rover there that indicates this is the right place to go. So we'll click on level 3 and we'll scroll down here. So we have a variety of different projects, but you can see here that we have a few that are particular to the rover. So we have the basic project, and then we have some of the extras that I was talking about. So what I'm going to do is I'm going to start at this one called the Phidgets Rover Kit. So this is the introduction to the Rover Kit, and then I'll talk about the extra kind of components we've layered on. So if I click on this, it's going to bring me to the main project for the Rover Kit. So just like the Getting Started kit, we kind of have the same setup here. So Rover Kit, introduction, we have a GIF, and we kind of are explaining what they're doing. So in this tutorial, basically they're going to be learning about how to use the rover, how to connect to the Wi-Fi hub, and they're going to be doing some basic movements with the rover, and then we'll layer on complexity as we go. So basically, using the wireless FinTub, using a DC motor controller to drive your rover, and then using a sonar sensor to avoid obstacles. Okay, so basically, and then as usual, you have on the left-hand side of the page, you have where you are in the course. So if you're using this this would be more so when you're actually in class, but if you're trying to check the progress of a student, assessing them as they're going through this, you can kind of use the left-hand side as an indication of where they actually are in the course. So next I'm going to go to parts. So we've already covered this in our kind of first part of this webinar. But again, this is something that you could use at the end of the semester. So, the student has their name on the box, and then you can use this part to kind of inventory the kit and make sure that they have everything that they should have. And if you need replacements or whatever, then you can figure it out at the end of the semester. So the next step after that is the assembly. So Phidgets Rover Kit assembly, again, we're on the assembly on the left-hand side here. As I mentioned, so when you get the box, you can literally just take out the chassis, so it looks like this when nothing's attached to it. So students literally just lift that out, and if they flip it over, you can see how the battery comes pre-installed. So again, we're kind of targeting computer science classes, so we're not necessarily focusing on how to build the rover and all of that. It's more like, okay, we're going to focus on programming in this step. Okay. And again, as I mentioned, so how students so they basically pull out this kit from the box, and all they're doing is they're using some dual lock. So as you can see in that photo, I have some dual lock on my sonar sensor, and there's some dual lock on the rover, and all you're doing is just kind of sticking it on there. And then Michael's just saying, I like that the modules are multi-use and replaceable plastic case. So are you referring to the rover? This is like an aluminum, but as an extra activity, they could design and build their own chassis. Yeah, exactly. So the idea is that you get a really nice comprehensive kit for a fairly decent price. And then if you wanted to add on to it, or you wanted to if you had a better chassis, you could use the motor controllers to control like a better chassis or anything like that. So there's definitely possibilities for expansion, which is awesome. And then, yeah, just to answer Michael's question, so this is like a metal, I think it's aluminum chassis. I kind of forget now. It's been a while since we designed this, but yeah, it's a pretty decent design in terms of how long it will last. Okay, so I'm not going to go through all of the steps, but basically the idea is that the students are using dual lock. They're placing the Phidgets on top, and there's a little bit of wiring in this project. All they're doing is basically there's a little screwdriver that comes in the kit, just a little screwdriver like this, and all they're doing is using the screwdriver on the terminal blocks to attach a few wires, but we try to keep the wiring to a minimum. So it's pretty simple. There's nothing too complex going on there. And once they have it wired and set up, you can just leave it, and you don't have to, if you're not taking it off and on, then you don't have to touch it again. And aside from that, all they're doing after that is basically making connections from the rover. So again, it's the vint cables. So it's basically just doing these connections where you're plugging in with the vint cable and unplugging. That's the most complex that it gets there. And at the end, we're going to be connecting the battery. So I'm going to actually do this right now. So the battery we have that green battery on the bottom, and it has a little connector that looks like that. So all we're doing is we are connecting the battery to this wiring harness. So again, it's just kind of a plug and play type thing. And Okay, so I'm going to move on to connect. So this is the part where we actually connect the rover to the computer. So every kit comes with a Wi-Fi USB adapter, which looks like this. So it's a little Wi-Fi USB adapter. And the idea is that I'm just going to let Ellen handle the chat. Well, I'm just going to continue with this, then I'll check back in a little bit. Okay, so the idea is that this Wi-Fi hub is broadcasting its own Wi-Fi, so you're not joining the school's network or anything like that. You're actually it's broadcasting its own Wi-Fi. You plug in your USB Wi-Fi adapter and then you join it. So I'm going to do that right now. So I just plugged in my Rover, and as you can see here, hopefully you can see this, there's a little red light here that's just on. So that indicates that my Rover is now booted. So what I'm going to do is I'm going to have to switch the screen I'm sharing quickly just to show you guys the how to actually connect to it with let's see. Okay, I'm going to share screen 1. Awesome, share. Okay, so I'm just sharing my other screen now so that you guys can see how I connect. So I'm going to click down here. I'm on a Windows machine, so I'm just going to go to my network tab. And then basically this is how the Wi-Fi hub shows up on your wireless network tab. So basically, and we have the steps up down here as well, but basically the network name will reflect the label. So I have a label on my Wi-Fi hub. So I'm going to find that network, and I'm going to put in a password, which I've already done. And then basically it will connect. Just a little tip here, if you exit out of this window and then you go back to it, it'll connect automatically. It seems like for some reason Windows like really plays out this animation of trying to connect, but it actually just immediately connects. So at this point, we can see in the instructions, I have this, so I'm gonna go back to my other tab here. So screen share number 2. Okay. So now I'm back on my right side here. So this is essentially what you're going to see is you're going to see you're connected to this Phidgets Hub 5000 and then the serial number, and you're going to see no internet secured because you're just making a direct connection to the hub. You're not actually on any network. But that is how you connect to the Wi-Fi hub. So this would be the same in any Wi-Fi hub project. So if you have this, set up to do a door, like a monitor people coming in and out of your classroom or things like that, it's always the same setup. You're going to your network tab, you're finding the Wi-Fi hub, and then you're connecting to it. So that is all you have to do. And then the next step is coding. So in reality, it takes, I set this Rover up yesterday, and it takes, maybe like 15 minutes, 20 minutes to get everything out of the box, everything connected, and actually connect to it via Wi-Fi. So it's really nice and quick. It's not going to take 2 classes to get everything set up. So I'm going to move on to the Move tab here. And then I think hopefully you guys can all see my let's see. Hopefully everyone can see my screen still. I have the right screen shared. I'm just going to quickly check the chat before I move on. Awesome. So Jennifer says she uses Raspberry Pi. The cool thing about Raspberry Pi, Jennifer, is that we're actually going to be, I'm hoping to get the document out soon, but we'll be creating a guide on how to actually use Phidgets with your Raspberry Pi. So if you do have Raspberry Pis laying around, you could, because it has a USB controller, you could actually just plug in your Phidgets to the Raspberry Pi and you could do some cool project with that. And yeah, so Michael's not just talking about networks. So we try to avoid being on the school network. So that's why basically this device just broadcasts its own Wi-Fi. And then we provide the USB adapter for your school computer. So that basically you're not touching the school's network. So just an example, we have a local class that has, 30 or 40 students every semester, and they have a setup where they have a group, like a lab. They're all connected via Ethernet to the internet, their school's network. so they can still access all the online content and courses. And then we give them the USB adapter, and then they're able to connect to the Rover, but still stay on their network, which is nice. So Karen says, so they're only Windows based. We do support Mac as well. So we're getting better support right now. I'm just waiting for, we're basically going to be having, oh, look, it looks like it's already going to be up here. So you can see up here that we have this Windows and Mac preference. This is actually not completed right now, but yeah, we do have Mac support, and by September 1st, it should be fully functioning on the website. But the instructions are slightly different. So we'll probably end up coming out with some webinars for Mac specifically. Okay, so now that I've kind of caught up with the chat, I'm going to move on to actually programming the Rover. So at this point, we've taken the Rover out of the box. We've kind of stuck on the Phidgets with dual lock, connected everything up, and we are now ready to program against it. So again, just like the Getting Started kit, you're going to see what you'll be doing in this step. So we'll be learning how to move the Rover forwards and backwards. And this is the point where, because we're assuming students have gone through the Getting Started kit, we're assuming they know how to kind of create the project and import the library. If they don't, they can revisit this configure section right here, and this will bring them to the Getting Started kit page where I'm having Python and Thonny. So this will bring them to the Getting Started kit page where it shows them how to redo everything. But at this point, we're kind of assuming that students have an understanding. I'm just going to set my preferences here. Okay. And they can basically just take this code and run with it. So this is my Python program that I'm going to start with. So just like the other, the Getting Started kit, we have the code that we want them to run to start. So I'm going to open up Thonny. So I like to use Thonny for the examples for the webinars because it's a really nice IDE. It just kind of works. So I'm just going to minimize this, make it a little smaller. Okay. So this is something they would have learned in the Getting Started kit, but the first thing I'm going to do is just create a new project or a new file, basically. And then, it tells me to call this file Phidgets Rover, so I'll do that, but that's not extremely important. So I'm going to save this as Phidgets Rover, and I probably already have one named that, so I'll just replace it. Okay, so now I have my Python file that's called phidgetsrover.py, and what I'm going to do is I'm going to take the code from this section and copy it in. So I'll use, so this is, sometimes if you change your preferences, you'll have to refresh to get that copy button to work again. We're just getting that fixed. But anyway, so I've copied the code now, and I'm pasting it in. And what I'm going to do is I'll run the code quickly just to show you guys the output, and then I'll just review what some of the differences are compared to the Getting Started kit code. So if I run this code using that run button, it will start to look for this device on the network, and then you can kind of see it working there. So if I put this on the ground, I have another webcam set up, so I'll just switch to that webcam quickly. Let's see, just to show you guys what it actually looks like. USB camera. So I've switched to the webcam that's kind of on the ground there. So if I run my code, you'll see it kind of move forward a little bit, just like in the GIF, and it'll probably hit that. It'll probably hit the box there when it runs, because it has no detection avoidance or object avoidance code yet. Okay, so that's what this basic program looks like. And then I'm just going to quickly talk. I'll switch my camera back, and then I'm going to quickly talk about what the code is actually doing. And then Karen, I'll answer your question. So I'm just going to quickly jump to Karen's question. Discuss how to use this virtually Are students able to send code to teacher who can? Okay, so maybe at the end, if you stick around, we can talk about how this could be deployed virtually, and I can give you some examples from some schools that have done this this past spring semester. So taking a look at the code, so what we saw was that the rover went forward and it ran into the box basically. So I'm going to just review the code a little bit. So from the getting started kit, this will look familiar. The only difference that you'll see in these import steps is this part right here. So because we're using the networked device, the Wi-Fi hub, we have this Phidget22.net import. So that's really the only difference. So when you're using the Wi-Fi hub, you'll always have to have this import statement there. Other than that, very similar to the getting started kit where you're importing the Phidget libraries and you're importing the device you're working with. So at the moment, we're only using the DC motor controller to move the wheels forward and backwards. We're not using any other sensors. So that's why it's the only one there. Okay, so after that, we have the import for time, which we have for virtually every program that we use. So again, that'll be normal and you're used to that at this point. Next, we have this part. So this is where you actually connect your program, that's your Python program or your Java program or whatever, to your rover. So this line looks for it over the network and says and tries to find that Wi-Fi hub. So this is important. If students don't have this, they won't ever be able to connect. After we connect to the wireless rover, we're creating an object for the left motors and the right motors. So basically what's happened here is we have a pair of motors. We have kind of two pairs of motors. We have the right side and the left side. And as we saw on that DCC 1003, there's two ports for motors. So basically these two motors are connected and these two motors are connected, and we put each of them into one slot on the DCC 1003. So that's why we have two of them here. And then we're setting the channel. So again, if we look at this device, you can see that there's a port 0 and a port 1. So that is basically what this line of code is doing. It's saying, hey, the left motors are on port 0 and the right motors are on port 1. After that, we're opening the device. So again, this is something that we've seen now in the Getting Started kit. Every time you create a project or create a Phidget, sorry, you address the Phidget and then you open it. This is what we're seeing here. The only difference that you may notice, it's not really a huge difference, but in the ones that we connect directly to, so the wired FinTub, like on the Getting Started kit, this number is usually 1,000 in those programs, and we've increased it to 5,000, and that is just the timeout. So it's just how long you wait to connect to this motor. So because everything's over the network, we just give it a little bit more time. Okay, so after I open it, this is where I'm actually using the DC motor controller to provide power to the motors. So I have this line here, motors at full speed, left motors.set target velocity 1, right motors.set target velocity 1. So this is basically the line that's actually providing, like telling the motor controller to provide power to the motors. And then what I'm doing in this one is I'm sleeping for 1 second and then I'm turning the motors off. So the range for this method is 0 to 1. So 1 is full power, 0 is off. And again, we're just sleeping for 1 second and then we're turning the motors off. So that is this initial project. You're moving the rover forward and then it just stops. So just like in the Getting Started kit, we have practice at the end. So again, this is for assessment and to get students to kind of dive into the code a little bit. So, we have change your target velocity to 0.5 for both motors. So that will basically decrease the speed of the rover to half, to 50, this will be half the speed. Change the sleep duration from 1 second to 2 seconds. So that's this line right here. And that will basically just allow the rover to move forward further. And then change your target velocity to -1. So by changing it to -1, oh, sorry, I made a mistake previously when I said the range was 0 to 1. The range is -1 to 1. So this will basically just change the direction. So if you have a negative value, it'll go reverse at full speed. If you have a positive value, it'll go forward for 1. So just like the Getting Started kit, we have the assessment there. And then we have the troubleshooting section. So if there's anything that they come into, any problems that they are seeing, they can kind of figure it out. Hopefully, try to troubleshoot it themselves before coming to you. And most of them in this step are pretty easy to figure out. Okay, so that is the move step. So at this point, we've actually been able to now move the rover forward. And I'm going to go to the next step, which is turning the rover. So this is kind of step 2. So now that you have it going forward and back, we want to see how we can turn it. So again, we have the GIF that shows what you can kind of expect from this section, and we have the code. So I'm going to copy the code, and I'm going to paste it into my project. So again, I'm just going to Control V, and you'll see that the only difference in this program is this part right here. So because we want to turn the rover, we basically want one set of wheels going one direction and the other set going the other direction, which will provide a turning effect. So what we're doing in our code is we're setting the target velocity on the left side to 1, so they'll be going forward, and we're setting the target velocity on the right side to -1, so those wheels will be going backwards. So again, we get that kind of crossing effect, which will turn. And we've also increased the time a little bit just to give it the chance to actually fully turn. So I'll put this on the ground here and run the code. So I'll switch to that camera. And if I run this code, oops, if I run it, we should see the rover do a little spin here. So that's it, it's turning code. Okay. Awesome. And again, at the end of them turning, we have some questions here, some practice problems. So this is something that you could, again, assess on. So, you know, are you able to complete practice problem 1? Are you able to complete practice problem 2? And these are just doing things like turning the rover in the opposite direction. So basically what you would do is you would basically just negate both of these. So this would be -1, this would be 1, and then they would go the opposite direction. And then we have another one where they are moving forwards, turning around, and moving back. So basically combining the last move section with the turn section. And as always, we have the troubleshooting at the bottom. So we'll move on to avoiding obstacles. So in this step, you will learn how to avoid obstacles using your sonar fidget. So just like the previous step, we have the GIF here, and now we're introducing the sonar sensor. So what we'll do is we'll copy this code. Again, we'll Control A, Control V to paste it in. And then what we'll do is, I think I'll run it quickly just to give you an example, and then I'll talk about the code very briefly because I guess I'm running out of time here. So I'm going to switch my camera to the other one. And then what we should see is as the rover approaches that box, it should actually stop. Maybe I'll just put this more in frame here. Okay. Oops, that's less in frame. So let's do that. And like that, say. So basically, as it moves forward, it should detect the box and stop. And that's using the sonar sensor to, so you see it moves forward slowly and then it stopped there. So that is using the sonar sensor. So basically the code is still running now. You can see the wheels moving, and if something approaches it, it will stop. And then it will go if something moves away. So I'll stop my code here, and I'll just really quickly talk about the code here. So we have, again, the networking. The only difference here is now we're using the distance sensor. So we're importing that line of code. We have the ad server as usual. We're creating the sonar now because we're trying to use that to detect the objects. And what we're doing is, in the while loop, we're using the sonar's distance to inform our motors. So, you know, if the distance is less than 200 millimeters, so if it's getting pretty close to something, stop the motors, otherwise continue. And then let's see if here you can see the output from the last program. So the distance values are streaming in, just like we kind of had values streaming in from the humidity sensor in the getting started kit. We have these now distance sensors values streaming in, and we can use that. So again, that's kind of the cool part about Phidgets, is that you can add complexity fairly easily by just, you're plugging in a sonar sensor, and now you have this distance data that you can incorporate into your Rover code. Awesome. And then at the end, there's a challenge here. So just like the getting started kit, there's a cumulative challenge that should kind of test all of your knowledge. So in this one, the idea is that you create a square and you have your rover drive around it. This rover it doesn't have encoders on it. So you're not going to get extremely reproducible. It's not going to do a perfect 90-degree turn and always do the exact same output with the same input. But the idea is that you're just kind of practicing the basic movements and exploring the code and things like that. We will probably end up coming out with a more expensive chassis that has encoders and has all these things, but for the price point, this one does not have the encoders. We're just trying to keep it as cheap as possible. Awesome. So after that, you are done the first step of the Rover Kit. I'm just going to quickly show you guys. So that was basically the course review. I'll just show you quickly the extra content that we have. So if you go to the projects tab again, we've now completed the Phidgets Rover Kit, and we can move on to the acceleration. Basically, it goes in order. So after they've done this, you should send them down to acceleration. This will just show them how to make their rover more responsive, so kind of more quick to respond to inputs. The thumbstick, so this will show them how to use the thumbstick, and they'll use actually the VIN hub from the getting started kit. So they'll plug it into their computer, they'll have the thumbstick connect to their computer, and then they'll drive around the rover wirelessly. And then we also have some other projects that use different Phidgets. So we have like a light sensor that's available, and you would put that on your rover and you would have kind of autonomous sensing. So those are the extra projects. So again, we recommend doing the introduction first and then kind of moving down to acceleration and then to the thumbstick. And this could be something, if you have a student who's doing really well at the Rover Kit, they can just go through the whole thing. If you have a student who's struggling, you can just kind of keep them on maybe the top level. Okay, so the next thing I want to review is how to get the rover. So just like everything else for education, you can go to the buy tab. So we have this buy tab up here. This will give you information on what's in the kit, what the price is, and everything else. And just a reminder, after you've purchased this getting started kit for your classroom, you have access to the 40% off on the other sensors and controllers and everything like that, which is great. So again, you would just press this buy button, which will bring you to the purchase order. That'll send us an email. You won't actually pay, right? You won't pay immediately. It will just send us, it'll send us an email and we'll send you a quote so that if you need to send that to a purchasing manager at your school, they can get that sorted out. Alrighty, I'm going to sign off then. Thank you everyone for joining. Appreciate it. Please check the future webinars and we'll talk to you guys soon.